Welcome to Lecture 3. In this video, we will talk about functions and relations. A function is a relation in which each x value, there is exactly one y value. The key word here is exactly one. The set of x values is the domain of the relation, and the set of y values is the range of the relation. The notation for a function is written this way, where here either f is a function or g is a function, and it is read as f of x or g of x. Now that we realized what the function definition is, where for each x value there is exactly only one y value, we need to know if we see an equation somewhere, we should be able to tell if it is a function or not. And for that, we have this test called the vertical line test. A vertical line will cross a function in exactly one point. That is what a vertical line test is. We will do a problem on vertical line test shortly, but before that, let us determine if the following are functions with only some ranges or some points given to us. To repeat once again, we have a function, and a function is a valid function only when for each x value, there is only one y value. So let me write it down here. For each x value, there is only one y value. So if you see here, 2, 4, 7, and 8 are the x values. So my x values are 2, 4, 7, and 8. And my y values here are 3, 1, -1, and 2. Let me write them down. So my corresponding y values are 3, 1, -1, and 2. Now we see that for each x value, for each of these values, there is only one y value. The good thing here is all our x values are all unique, so this would automatically make it a function. Let us do another example here. Let us first write down our x values and our y values. So our x values are 5, -2, 5 again, 4, 1, 0, and 4. Let's write them down. So we have 5, -2 here, 5, 4, 1, 0, 4. The corresponding y values are 3, -1, -2, 2, 7, -3, and -1. So we have 3, -1, -2, 2, 7, -3, -1. Again, here we have our definition, where for each x value, there is only one y value. Here we see that we have two x values which are similar, and here we have 2 of 5s and 2 of 4s. Here we see that 5 is mapped with 3, and here 5 is mapped with -2. Similarly, for 4 is mapped with 2 and -1, which goes against our function definition, where for each x value, there is only one y value. So here for the x value of 5, we have two different y values, and for each x value of 4, we have two different y values. So B, this is not a function, and this is a function. Okay. Now let us do this problem. Which of the following graphs represent a function? So for this question, we will use our vertical line test. which is where we draw a line, and it is a function only when it crosses the function at only one point. So let us do that. Let us try to draw a vertical line here. Once you draw a vertical line here, you see that it only crosses at one point. You draw it anywhere on this function, essentially, like here or here. Wherever you draw a vertical line, we see that it crosses only one point. That is why this is a function. In the second graph here, you draw a vertical line anywhere. You see that the line crosses it at 2 points. There's one, 2 points here and 2 points here. That means this is not a function. Let us repeat it here. We draw a vertical line. We draw a vertical line, and we see that it crosses at only one point, no matter where we draw the line. So this is a function. Just to repeat, what we did for this problem is just draw a vertical line on our graph and see how many times does the actual graph here intersect with the lines that we've drawn. If for one vertical line, if it only intersects once, it is a function. And if it intersects twice or more, it is not a function. And for these problems here, we just checked if for multiple x values, if it is different y values, for the same x values, if you have different y values, then it is not a function. But for each of x value, if there is a unique y value, that means it is a function. Okay, let us move on now to evaluating functions. To evaluate a function, we need to understand the notation. So here we have f of x as 3x. So if f of x is 3x, find f of negative 2. This means to evaluate the function f of x when x is negative 2. So basically, we have f of x as 3x, and we need to know what is f of minus 2. So the way we find f of minus 2 is wherever there is x, you substitute a minus 2 instead of the letter x. So in this function here, we see that we have an x here. So instead of x, we just substitute negative 2. So that would give us negative 6. So f of negative 2 is negative 6. Let us do some examples now. Okay, we are given if f of x is negative 5x plus 3, we want to find what is f of minus 4 and what is minus f of x. Let us do this one by one. We first do f of negative 4, which means wherever there is an x, you substitute it with a negative 4. So what does that mean? So we have minus 5. Instead of x, it becomes negative 4 plus 3. So negative 5 times negative 4 would give us 20 plus 3, just 23. So f of negative 4 is 23. Now, the next one here is negative f of x. So there's nothing to do with x here. Oops, wrong pen. There's nothing to do with x here, but it's saying negative of f of x. So if we have f of x as this, negative of f of x means negative of whole of f of x, which is minus 5x plus 3, which will give us 5x minus 3. So this is our negative f of x, and this is our f of minus 4. So evaluating functions is basically substituting. So here we are substituting minus 4, and here we are substituting the entirety of minus f of x to get minus f of x. Okay, let us do some more examples. Here we have f of x equals x squared minus 6, and we want to find f of 4 first. So f of 4 is wherever there is an x, you substitute a 4, so you get 4 squared minus 6. That's 16 minus 6, which gives us 10. Now we have f of x plus 3. So every time there is an x, we need to substitute x plus 3 now. This gets a little tricky, but once you understand how the evaluating of functions work, it's pretty easy. One trick that I have learned is every time you see an x, so forget about what the question is asking. Once you know that it's something where you have to evaluate, you see your function here, right? So now what I would do is every time there is an x, I would just put a parenthesis and leave it blank. And now here we have parenthesis square minus 6. And coming back to our function, we know that we have to evaluate this function at x plus 3. So everywhere we had a parenthesis, I would just substitute my x plus 3. So now, just like in the last video where I said a plus b whole square, this is an important formula to just keep it in your mind, where you have a squared plus 2ab plus b squared. So here our a is x and b is 3. So a squared is x squared plus 2ab is 2 times 3 times x, which is 6x. And b squared is 3 squared, which is 9 minus 6. So this is x squared plus 6x plus 3. This is our f of x plus 3. Okay, another example here. We have our f of x as this function. We need to find f of negative x and f of x plus h. If you look closely, you might think that we did something like this earlier, but if you look here, we did negative f of x, and here it is f of negative x. These two are very different things, and we will know why now. Just using the trick I used before, where I put a parenthesis every time there is an x to make things simpler and to reduce errors, we have 3 times parenthesis minus 4 divided by 2 times parenthesis plus 5. And now here we are finding f of negative x. So every time there is a parenthesis, you put a negative x in it, and then you evaluate. So it's negative 3x minus 4 divided by negative 2x plus 5. This is f of negative x. Just to compare, let us also do negative f of x to see that it's not the same thing. Negative f of x just means you have a negative, and the whole of f of x, which is 3x minus 4 divided by 2x plus 5. Which is equal to 3x plus 4, negative 3x plus 4 divided by 2x plus 5. When you compare this with this, we see that they are both different. So we should be very careful if we have negative f of x or f of negative x here. Okay, let us do the next problem here where we are asked to find f of x plus h. Same thing again, 3 times parentheses minus 4 divided by 2 times parentheses plus 5. And instead of the parentheses here, every time there's a blank space, you put x plus h. And you do 3x plus 3h minus 4 divided by 2x plus 2h plus 5. And that is our answer. You will see this function, this evaluation, repeat multiple times throughout your mathematical journey, because this is something very, very crucial in mathematics where it's called the derivative, and we will talk about it probably in the future videos. Okay, another problem here. This is worded a little differently, and we are said that if f of x is so and so, find the values of x such that f of x equals 11. So what this essentially means is we are given f of x equals 11. So instead of f of x here, we have 11 equals x squared minus 2x plus 3. And we are asked to find what this x value is. So this is basically asking us to solve this quadratic equation and find the roots of it. Let us do some arithmetic here. I like to switch all the letters to be on the left-hand side. So let us first do that. So I'll just switch the function this way. And then we'll continue our solving. So we subtract 11 on both sides. So you get minus 2x plus 3 minus 11 equals 0. Oops. So x squared minus 2x minus 8 equals 0. So there's two ways of solving this. We can either factorize it or we can use the quadratic formula. We'll do both. So what is the quadratic formula? It is minus b plus or minus root over b squared minus 4ac by 2a. This is where our quadratic function is ax squared plus bx plus c. Okay, so let us solve it here. So our b is minus 2 here, so it's 2. Let me use a different color. So it's 2 plus or minus root over b squared, which is 4, minus 4ac. So it's minus 4 times 8. Yes, 4 times negative 8. You have negative, negative, which becomes a positive. So it's 4 times 8, 32, divided by 2a. So this is equal to 2 plus or minus root 36 by 2. So this is 2 plus or minus 6 by 2. So I intentionally didn't do plus 6 or minus 6 because we already have a plus or minus, so it kind of nullifies. But if you didn't have a plus or minus, then you would have two conditions where root 36 would be plus 6 and minus 6. So let us first do 2 plus 6, which is 8 by 2, which gives you 4. And then we have 2 minus 6, which gives you minus 4 by 2, which is negative 2. So our roots are 4 and negative 2. So you would write this as x minus 4 and x plus 2 equals 0. So our x values are 4. So our answer is 4 and negative 2. Just to verify, we can plug in these and see if we got the right answer. So let us first look at 4. 4 squared is 8. Sorry, square is 16. Minus 4, 2 is 8. Plus 3, which will give us 19 minus 8, which is 11. And that's what we want. F of x is 11. And let us plug in the other ones. Oh, this is actually a evaluate function now. Let us do f of minus 2. So you have f of minus 2, where instead of x, we again put the parentheses, square plus 2 times, whoops, this is a negative, negative 2 times parenthesis plus 3. Now we have negative 2 here. So this is 4, that's plus 4, and that's plus 3. 8 plus 3 is 11. So now we have verified that our answer is correct. As I said before, we can also directly factor this instead of doing the quadratic formula. And that is, how would you do that? So here our quadratic equation is x squared minus 2x minus 8. So we want to split the between value in such a way that you get something like this, right? So you want to split the between in such a way that their sum or difference of the coefficients is 2, but the product is 8, right? So let us think about all the values, all the factors of 8, where you're multiplying two different numbers and you get the value 8. So 8 is, you can write it as 1 times 8. You can write 8 as 2 times 4. And you can write 8 as 4 times 2, which is the same thing as 2 times 4. And finally, we have 8 times 1. So let us see difference or addition of any two, would it lead to 2? Here we see that these two have that property where 4 minus 2 is 2. But here we have a negative 2, so we just have to make it minus 4 plus 2, which gives negative 2. Let me erase this so there's no confusion. And so now, let us split the minus 2 into two terms. That would be minus 4x plus 2x minus 8. Now, we club these two and these two terms. From the first clump here, we see that we can take x common. So we have x times x minus 4, right? And then from the second term here, we can take a 2 common, which is 2 times x minus 4. Now, we can take x minus 4 common, which will make it x minus 4 times x plus 2. And then we get the same answers where the x value is either 4 or negative 2. And if you see closely, we see that this, this is same as this. I forgot one main thing is equating it to 0 at all stages. And now you see that they're equal. So no matter what way you do, you'll end up with the same answer. It just depends on how, which method is faster for you and which method makes more sense to you. You could just follow the same method. Okay. So last question here for this video. Here we want to find the x-intercept and the y-intercept of the function f of x equals x squared minus 4. If you remember from the last video, x-intercept is where the graph meets the x-axis, that is where y equals 0, and y-intercept is where the graph meets the y-axis, that is x equals 0, right? So now if we want to find the x-intercept, we want y to be 0. So f of x here is y, so y equals x squared minus 4. So we want y to be 0. So we substitute y as 0. So we have x squared minus 4 equals 0. X squared is 4. We get this by adding 4 on both sides. And x is equal to root 4, which is plus or minus 2. So our x-intercepts here are 2, 0 and negative 2, 0. Intercept should always be written as an ordered pair. Now let us find the y-intercept. So y-intercept is when x is 0. So you have y, wherever there is an x, you substitute a 0. So you get a 0 squared, which is 0, and negative 4. So right there you have your answer, y equals negative 4. Let us write it as an ordered pair. So our y-intercept is negative 0, let me erase this. This is going to be 0, negative 4 is our y-intercept. And this is our x-intercept. Both of them. I'll go over a quick recap of what we've gone over in this video. We first started with the definition of the function, and we just got a little bit of a peek into what a domain and range is, and we will go more over it in the next video. We learned the notation of f of x and g of x. And then we learned about the vertical line test, where you just draw a vertical line on your graph and you see if it meets 1 point or more. If it meets 1 point, then it is a function. If not, it is not. And then we saw how to determine if something is a function when you're just given some ordered pairs. And we also wanted to check if things are a function, where we did some hands-on with the vertical line test. And then we saw how to evaluate functions, where you either substitute for x or for y. And then we found how to solve different evaluations of different functions. Next video, we will talk about the domain and range of the function. For now, this is it. Thank you for watching.